resources for malware analysis along with some real life experiences added. I've planned this session as a beginner point of view and explain things accordingly. So let's get going. So as I mentioned, defensive side. What exactly is it? If I talk about categorization of cybersecurity professional working area, it can be red team, blue team, and purple team. Out of which, red team is offensive side, blue team is defensive side, and purple teaming is both combined. Defensive side has multiple subdomains such as digital forensics, incident response, malware analysis, reverse engineering, threat hunting, etc., and the list goes on. In this, I'm going to talk on malware analysis and its relationship with reverse engineering. Since Windows operating system is the widely used OS, majority of malware attacks are on it. Therefore, this presentation is made keeping Windows OS as a compromise system. What is malware analysis? In simple terms, any type of software that causes harm or damage to person, system, or network is a malware. It's generally a backdoor, Trojan, ransomware, virus, worm, and so on. So, why is it important to analyze malware after it has done its task? You might be thinking, right? Generally, it's analyzing files to determine whether they're legitimate or malicious. Either way, you need a way like to be able to differentiate between good code or software from the malicious one. Here are a few reasons, or I should say, motives to perform malware analysis. The first one is malware detection. To better protect your organization, you need to be able to identify compromising threats and vulnerabilities. Second one is threat response, to help you understand how this threat works so that you can react or work accordingly to them. Third one is malware research. This can help you to better understand how specific type of malware work, which we're going to look upon in the later section, and like where they're originated and what differentiates them. And if I talk about Windows perspective, like what we are currently doing right now, malware can be an executable, a DLL, or a document. So now, if I talk about approaches to malware analysis, generally it could be broadened into two categories. First is static and second is dynamic. Now, if I talk about full-fledged stages of malware analysis, it is as follows. Where initially we use automated analysis to narrow down the surface to look upon. There are various open source platforms such as Cuckoo, which you can see at the bottom right corner, which does the initial lookup for us, saving our time when the data or systems are in large number. Later, to look deeper into specific files, which we might have got as a lead from the automated analysis, we can use static property analysis. All of this will be discussed in later slides in detail. So, as you go up the pyramid, which generally happens when you are like tackling a difficult scenario, you might have to run into this malware, or you might have to run the malware into the sandbox environment to analyze its behavior. It's working, and the most complex part is when you have to reverse the whole code or executable to understand its working. Now, basic static techniques. So the motive here is to understand the file and its property so that we know that what we are working on and have some prior idea about the file. So here, as you can see, I have mentioned some point like we can check signatures with antivirus, we can do hashing. There is a pretty good website named as VirusTotal which can be used to analyze the file based on hashes and its file properties. Then we can use string utilities. It is present in Linux as well as in Windows as this internal tool to check and print at least 3 ASCII characters so that whatever characters are present in the binary or executable, we can have an idea from looking into that. Microsoft executables are termed as portable executables or PE files, and it contains valuable information. A PE file has the following information in it. So it has header, which consists of imported libraries. Then it has file section, in which it has .text, .data, .rdata, .rsource or .rsrc. Here, the most informative one is .txt or .text. Apologies for that, as it contains the executable instruction, and the tool used to look these is PEView, the one which I have shown here on the right hand side. The tool name is PEView, and it can be used to check different sections or parts of the portable executable. Now, basic dynamic analysis. After understanding the file and its property, we try to see the malware by analysis. After understanding the file and its property, we try to see the malware by running it, what actually it does, what activity it does. This has to be done in a sandbox environment, usually done in VirtualBox, VMware, or some other hypervisors. Some things to note here is do not connect USB or any peripherals to the sandbox environment, and keep the host patched, because there are some malwares that can jump outside the VM. So now, to run any exe file, it is directly as simple as that. Just double click and run it. Now to run any DLL file, we can use run dll32.exe to run DLL along with the export function. Now the export function, it can be seen by the tool which I have just now discussed. It is PEView. Accordingly, we can run the malware in the environment, and we can check what activities that it does. There are some basic tools to monitor and analyze the activities while running the malware. Now I'm talking about dynamic analysis itself. So what tools could we use to analyze? So some of them are on the top left, you can see regshot. So what regshot is, it helps in understanding the registry. So how registry helps malware, like it determines how malware is installed in registry, and it is generally used by attacker for persistence method. Now this tool captures registry before running the malware and after running the malware, and then displays any change made by the malware or any process which we are running. For example, any keys deleted, any keys altered, or any new keys added. All of the brief information is given to us in a text file, which can be very helpful to analyze the registry. On the right hand side, just next to it, you can see is procmon. This is the process monitor. It is generally used to monitor process as well as thread activity, some network activity, file system, as well as registries. It's run before the malware is executed, and later it analyzes the change. Like before we are going to execute the malware, we have to run these tools. After that, we have to run the malware so that it can analyze the change and give us a brief summary, which we can look deeper. And the most interesting feature of this is the presence of filters. We can use different filters to sort out our findings. We can exclude some of the processes which are legit, and we can narrow down our surface to which we have to look upon. Now, the last one, which is on the bottom left corner, is Wireshark. Majority all of the malware has a command and control center, which is at the attacker side, where all the data infiltration is done. There has to be some network traffic generated whenever a malware is running. So to check any unnecessary outbound network traffic, we use Wireshark to intercept network traffic. Okay, reverse engineering versus malware analysis. So the part which have haunted me for a long time. So you might have a question, or you might ask me, like, do we have to need reverse engineering expertise for being a malware analyst? And is reverse engineering same or different as compared to malware analysis? So the answer to this is like having additional set of knowledge is great. And yes, reverse engineering is sometimes necessary for malware. As I said in the pyramid, the topmost and the critical phase when you're tackling any malware could be when you have to reverse the whole whole executable binary. But the difference, as per me, is in malware you have to understand what the executable does. So generally, you focus on the interesting part of executable rather than dissecting the whole executable, which is generally the motive in reversing. And I'm not an expert, so that I can give you full-fledged methodology or resource to make you a pro. But the way that had helped me to overcome my phobia and to understand the reversing part easily is the divide and conquer technique. So what I did, I just used to write different codes and compile them and then analyze using disassembler. For example, if like as you can see on the screen on the left hand in the middle, I have a code, and on the next to it, right to it, I have different code. So the one is for local variable and the another one is for global variable. So accordingly, we can see on disassembling both of them what is the difference between them, and then I research what is like researching about the unknown part or keyword which I do not know or which is totally new to me. And yes, of course, having idea of assembly language and computer architecture is a must. There has like this has certainly helped me personally to at least learn reversing to that extent that I can say that yes, I can do malware analysis to some extent using reverse engineering. And I hope it could help you to all. And personally, I have found this book, Assembly Language for x86 Processor by Kip Irwin. It is much easier to understand as a complete beginner. So you could give it a try. Now, Windows internal. One of the most important topic that helped me to understand different type of malwares and their possible functioning just by looking at the Windows API calls and the Windows function that malware is using. Before directly jumping into the internals or like different malware, how they are created or what functions they are using or what Windows internal API they are using, let's just do a brief informative stuff about Windows internals. Processes. Malware inside Windows either run as a process or thread. Without it, it cannot run. It is generally seen as an executable or a DLL. So what DLL is? DLL are an executable that export functions for application use. Some malware can actually be a DLL. This way, it can load itself into other legit processes. Now, the Windows function which is used to create a new process is create process, which you can see on the screen itself. Threads. Now, processes are heavyweight and threads are lightweight process. Like threads are actually what Windows execute. Within a process, threads share memory, but they could have different stack and registry. Malware might create a new thread to execute within a running process. Also, it can create multiple threads for input and output. For example, one might read from a socket and one might send data back to a socket. Services. System services, they run with system privileges. It has no process or thread of its own. Like it is similar to Linux daemon. Like it runs without controlling terminal. Windows use GUI, a control center, to interact with them. Now, to look for the service info for a local system, it can be looked in the following registry key, which is HKLM, system, current control set, and services. The function which is generally used by any binary and executable to start services, open SC manager, create service, and start service. Network API. Network API is used to send info to the command and control system or server or simply if I say back to the attacker. In it, BSD sockets are used and WSS startup function is called before using network API. And the other calls which are used in networking or network related Windows calls are internet open URL, internet read file, and URL download to cache file, which can be seen in the executable itself when we are generally disassembling or dissecting it. Windows registry. So what Windows registry is? It is centralized database which are HKLM, HKCU, and it can be seen on the screen itself. I'm not taking much of a time to just go through it. So HKLM is used for storing the global settings, whereas HKCU is used to store settings specific to a current user. HKey class's root is used to store information of defining types. HKey current config stores the current hardware configuration setting, whereas HKey user defines settings for all the users. Now the function which is used by any binary or any malware to interact with the registry is reg open key ex, reg set value ex, reg get value, and reg close key. Now the common malware behavior. So the list is not this much. The list is very big, but the most general seen malware behaviors or the type of malware are as follows, which is downloaders and backdoors, process injection, DLL injection, direct injection, process replacement, APC injection, registry persistence, and DLL load order hijacking. So downloaders and backdoors. These are the one of the most simplest piece of malware, which it can be identified if we found these two API in the executable. The first one is URL download to file and winexec. Generally, this open the port 80 and runs command.exe or netcat, like netcat.exe. It create process call for command.exe, and another way is the multi-threaded technique. Process injection. It is the simplest way to launch malware, whereas it is easily detectable. It is a common method of launching the malware, and it has two types: DLL injection and direct injection. It uses two Windows API call. The first one is virtual ex, which is used to allocate space in the external process memory. The next one is write process memory, which is used to write data to the specific allocated space, which has been created by virtual alloc exec. Next one is DLL injection. So DLL or dynamic load library, it generally forces a process to load malicious DLL. It is done by passing a malicious DLL to a process that calls load library and force the process to load DLL automatically by calling DLL main function. The whole process involves several steps. The first call could be seen as open process. The next one will be virtual alloc ex. Next, window write process memory. Next, DLL injection or dynamic load library injection. So it forces the process to load malicious DLL. It does so by passing malicious DLL to a process that calls load library and forces the process to load DLL and automatically calling DLL main function. This process involves several steps which can be seen in the screen, like what are the functions and calls used by this malware behavior. Next one is direct injection. It is similar to DLL injection, except it does not force process to load DLL. Instead, the code injected directly into the process memory, which is generally a shell code. Okay, and it is more flexible to execute, but it is, on the other hand, it is more difficult to write. And similar functions are seen in this as well, like the one which are used in the DLL, like virtual alloc ex and write process memory, create remote thread, etc. Process replacement. Now, unlike injection, this technique completely overrides the memory space of a running process with a malicious executable. Now, how it is advantageous? Because it can disguise malware as a legitimate process without crashing even the real program. Generally, it is done in the when the process is in a suspended state, and the call which is used, or which is the parameter which is passed to other calls, is create suspend. From there, the process needed to be replaced section by section. Now, APC injection. What APC is? APC stands for asynchronous procedure call. So it has the capability that direct a thread to execute some other code prior to its regular execution. So each thread has a key of APC attached and waiting to run. So what malware can do? Malware can try to inject itself into APC queue and force that thread to execute malicious code. And to check whether the malware is related to APC injection, we can check the presence of queue user APC API in the binary. Now, registry persistence. So malware generally have some set time or date after which it will no longer run, and that helps other new malware to run without conflict. So how malware use registry as persistence? There is a term known as auto run key. So whatever the values or entries are in that key, that will run automatically whenever the system is rebooted or starts. And the location of that auto run key is HKLM, software, Microsoft, Windows, current version, and run. So this specific key in the registry can be used by malwares for persistence. So it is a great thing to look upon first to check whether the malware currently exists or not. The last one is DLL load order hijacking. So what it does, it takes the advantage of search order. So what search order is? So whenever program is running Okay, and it needs some external libraries for that program. So there is a specific order in which, or in the hierarchy of which, the program will look upon. So the first place the program will be directory from which the application is loaded. Second place will be current directory. Third place will be system directory, which is system32. Second place, the fourth place will be 16-bit system directory, which is system. Fifth place is Windows directory, which is Windows, and the last one is any directory which is present in path. So how like order hijacking work is, so for example, if there is any exe file in Windows directory and it calls to an external library which is in system32, or if I say it is in third level of the hierarchy, system directory, system32. So whenever that exe is called, the DLL will be looked from the starting, which is from the directory which the application is loaded. Now, if I create a similar DLL, which is malicious one, and I keep it in a directory same as that application. So instead of looking for legitimate DLL, the exe file or the executable will load the malicious one, because as according to a hierarchy, the DLL file is present in the directory from which the application is loaded, rather than looking for the actual DLL which is loaded in system32. So these were the common seen malwares in the real world scenario. There are many others, but it would be a bit highly advanced, or many advanced adversaries attack. So I'm not going to that specific point. This talk has been made just for beginner perspective, so anyone who is willing to look or start in the defensive side, specifically malware analysis, they can, I think they will learn something from this. And if I talk about resources, uh, then I would say Google is the best resource you can look upon. Like, you just have to narrow down what problem you are specifically having, and you just have to look upon it. If you say to me or say to anyone who is at least intermediate level in their domain, if you say to them, like, for example, if you say just to me, I'm not feeling comfortable in malware analysis, or how should I study malware analysis, I'm getting troubles in studying malware analysis. So this is a question one. Another question someone will ask, I'm not able to understand how injection is, or how to identify injection in the malware analysis. So you can understand that the difference between you generally say about, I don't understand a broad topic, no one will ever give you a that much time to explain you whole thing. So better to start right now, look upon things, Google it, research whatever new thing you find, and if you find any specific issue, even Google or internet cannot help upon, then you can look upon your known person who are already into that field, and then you're good to go. Thank you so much for listening to me, and I hope you have a great time. Stay safe, enjoy, be happy. Thank you.
So yeah, guys, it is the time for our quick Q&A session. If you guys having any kind of confusion regarding the learning for today's session, do ask in the Q&A session. We will be answering there. We will be active here for more 2 to 3 minutes. So do ask the questions immediately.